Let me share my screen. We will now talk about some extensions to the functions. I mean, some more concepts on the functions, and then go to the next section. I'm sharing my screen. Okay, we'll talk about the higher order functions. So we have seen simple functions giving parameters to the functions, returning them, returning values and all. So there are some more things that we need to understand, like higher order functions. Higher order function is nothing but you can call one function within another. So that is called higher order function. A function which is actually calling another function is called a higher order function. For example, let's say we have a function called a square, and we give a parameter x to that, and let's return x star star 2, which will return the square of number. So this is a function, right? So let's say we want to apply this to a list of numbers, right? Let's say we have a array also. Numbers is equal to 1 2 3 4 5. So let's say I want to apply this square function to all these numbers, and I want to get a result in just one line, right? So let's say we define another variable called squared numbers. Now we take this square function into another function called map function. So there is a built-in function called map that will actually map what your list to a function and give you the result. For example, here we want to map the function called square, which we have already defined, to the list called numbers. So what this is going to do is, this is going to take each and every number in this numbers list and then apply the square function to that, and that is going to return back as a list. So we will actually um, typecast that to a list so that we get the result as a list. Okay, and then let's print it, squared numbers. Let's run this. Spelled it wrong. Okay, now you can see that each of this number is actually squared. So this is, in this case, the map becomes the higher order function that is actually executing another function called square. You can do this in many multiple situations. It's really helpful. There are many built-in functions that will take lists and apply the function that you are giving into those lists. Map is one of that. You will see more if you I mean in the later sections probably. Okay, any questions on this higher order functions? No. Okay.
Anything that needs to be done special, or is it just your parameters can be a function? Like if you want to create a higher order functions, your parameters can be values, or it can also be functions. That is how you create HOF.
This parameter is a function. So this is a function. This is the values that you will pass as a parameter to the function every time. So
Correct.
there's a list, and from that list you are going to take each and every item and pass that as a parameter to this function and get the result.
Okay. I'm just trying to arrive at a general formula or something like this. Just like map, if we want to create a do something method, we can pass another functions and the data to be sent to the function as the second parameter. Is that something like that?
Yeah, this parameter is something that you want to apply that to every object or every item in this list. Yeah. Okay. So now let's talk about lambda functions. So lambda functions are nothing but in Python world, the term lambda means you can do it inline, right? You don't have to define a function with a name and all. If you want to just do it one time within your line of code itself, that function is called a lambda function. So you can do that by, let's say we have a numbers. we have a list of numbers and we want to say get the even numbers, right? Even numbers from this list. So what we will do here, let's say we will use the filter method, filter built-in function. Okay, here instead of calling square as a function, we will give a lambda function here, which is like we have not defined any function now. We are just going to define it here. We'll define it by lambda. And what we are going to do is we will let's say we will call x as a function. I mean, whatever parameter you are giving into the lambda function is called x. So whatever comes in, it is going to apply, take that x and applies in the line that you have after this colon. So what I'm going to do is I'm going to say x percentage 2 is equal to 0, which means that I'm actually taking this x and applying this piece of code. So it is going to tell me whether x percentage 2 means it is going to give me a remainder after dividing by 2. So the remainder, if it is 0, then it is going to be an even number. So this will return me a true, right? So this will return me a true. For any number that I'm giving here, it is going to return me true or false. Okay. So what is the number I'm going to give? I'm going to give all these numbers. I'll just give numbers as a next parameter. So here the first parameter is a function. Second parameter is the numbers that you are giving. In this case, I am actually filtering it, which means that it is going to give me everything that is going to have a value of true when this lambda function is executed. So from these numbers, it is going to check whether one is actually giving true here, two is actually giving true here. So any number, it will create an array with true, false, true, false, true, false, and I'm going to filter that. So which is going to give me only numbers with true, right? So let's see what is coming, and we will also typecast it with the lister. Okay, let me print the even numbers. You can see that 2468 is actually it is filtered and it's given even numbers. So this is you can apply lambda function anywhere. It's just one example where you can apply. Any questions on this one? Okay, these are some of the things that you can use when you code, because you don't have to just keep on writing functions. These are different techniques that you can use. You will, if you practice, I think you will be able to use it where you need. Okay, next one we will be seeing about is recursions. So recursions you all would have done in your current programming languages wherever you are working. So it is like calling the function within itself. So you want to call a function within the function. So that is called recursion. So one good example for that is factorials, right? So factorial is like you will multiply the number. If you give a number, you will be multiplying the previous number to previous number to until it reaches 1. So that is a recursive multiplication. So let's see how we can do that. Let's say do a factorial as a function, and let's pass a number n. So this is going to take any number. So for that number, it is going to find a factorial. So if n equal to 0, when n reaches actually 0, so this is going to return 1. If not else, it is going to return, because if n is 1, there is I mean the value of factorial is 1. Otherwise, it is going to recursively call this function. So n into n minus 1, right? So factorial of n minus 1 is what we want. Factorial of n minus 1. Now this factorial is going to call this function again. So that will go with 4, and next time it will go with 3, and finally you will get the result. So this is recursively being called until it reaches 1. Okay, now this is the function where factorial is called within factorial. Let's say results will make use of this function. Let's say factorial of 5, and we will print the results. That gives you 125 into 4 into 3 into 2 into 1. So that's how it is. You can, you can see the application in many scenarios for this. Any questions? Okay. Okay. The final one or the last one I want to tell us variable length arguments. So we know that it is going to take, you know, parameters. So let's say we don't know, how many parameters will be passing, and we want to make use of everything or anything from that. We can also use something called, variable length arguments. So the way to use variable length argument is, let's say, we will define another function. This time we will do a multiply whatever number is coming. Let's say if you pass 5 numbers, it should multiply everything. It should pass 3 numbers, it should multiply everything. So we don't know how many numbers will be passing. So in that case, you can do a star and args, which means that the star means that anything that you pass, it can contain any number of values in that. Okay. So we will, okay, let's say first we will do a result equal to 1. We will define the result. And then for each of the value that is coming in this arguments, for number in ORs, which tells you that for everything that is available in this ORs, loop it and multiply that with the result. Result star equal to number. This is same as result equal to result into number. Right. So and you can return results. So for any number of arguments that you are going to give, it is going to, you don't have to define a comma b comma c comma d and all. You can just say star arguments and loop through the arguments, and you can, get the function working. So result is equal to multiply. Let's say I will be passing 4 comma 5 comma 6 and print result. So that prints. And if I want to pass more, don't have to modify the function. I just, I can provide anything here. Uh, oh no. So, why it is printing 120 only?
In return, it is
Because
results.
Oh, no, sorry. Yeah. Okay. So 4 into 5. Okay. 4, 5, 6, 120, and you can see that gives the value. Okay. This is variable length arguments. Any questions? These are different ways you can use the functions. Just I wanted to, provide this knowledge so that you are aware of these things are available and you can make use of it. Okay. So
Prem,
no, yes.
before moving on, is there anything like how we have in TypeScript very useful things like default parameters, optional parameters, right? What is the equivalent in Python? Is there anything interesting over there?
Yes, optional is there. You can provide an argument and you can, give a default value to that, which means that it will assume that value. I think that I covered that in the last last section. Yeah.
Okay, I'll look it up.
For example, as factorial, if you say, n needs to be passed, in case you don't pass anything, you can probably say, default value of 4. So in that case, it will take that default value, even if you don't pass anything.
Okay.
Let's run this. Okay. But if you pass a value, it will take that and do it.
Okay. That's default value.
Default, yeah.
Any keyword for mentioning that this is an optional parameter? I think the star orgs is That is for telling all the parameters are optional, or there are more parameters coming inside.
Yes, there are, many parameters coming inside.
Okay.
That's what it's saying. It's
In TypeScript, we
and
have that, right? Like we have the initially mandatory parameters in the front, optional parameters to the right, we will put it, right? Something like that.
yes, if you have multiple parameters and you want to specify everything together, for example, let's say we'll have one function df, you know, let's say sum. Okay, so maybe you are expecting more, at least three values, a comma b comma c, and then anything else can be optional, right? So d is equal to 0, e is equal to 0, so you are defaulting it to zeros. So
Okay.
when you call that, you will, these a b c are expected. So if you don't pass this, it is going to fail.
Okay.
But d e f are not you don't have to pass it. If you pass it, it will take, otherwise it won't.
Yeah. Okay.
Okay. Anyone else? Any questions? Okay. So let's move on to the next section, which is packages. So what are packages? In If you are familiar with Java, then any module, in any inbuilt module or anything that you will create as a executable, that is called a package, right? So in Python, a similar one is called package. So a package is a collection of Python modules organized in a directory hierarchy. So whatever, you are going to, let's say you will have 100 functions, and all these 100 functions will be packaged and given um, uh, as an item. Then that is called a package. You can actually deploy it, and you can make it available for others, and people can download, and just they can use your package. There are many such packages available, many open source packages. It is going to, the Python module is a single file containing a Python code. So within a package, you will have multiple modules. So within every module, you will have Python code, and you will combine that everything into a package. The packages, improve the code organization and simplify code sharing and reuse. For example, let's say if I want to use a open source package that is available to convert PDF document into text, there is one package available. So I can go ahead and download it, use it in my program, and I will just use the function, necessary functions I want from that package. That package may be having n number of functions, but I may be just using one or two. So I will just pull that package and use it in my code. So that's how it is. So why we use Python packages? It is to organize the code and maintain readability and maintainability. Not only outside packages, you can actually package your code to have it shared within the teams and all, right? Enable code compartmentalization to avoid naming conflicts. So this way it can you can have the same name in different folders. So if you are uh, if you're actually giving the compartmentalization like that, you don't have to worry about the naming. You can you will refer to one particular module in a in one particular folder. So that way it will not give conflicts. And it simplifies code sharing. You just package it and share it with anybody can just pull it and use it. Okay. And it helps to manage dependencies and versions. So basically, when you have some uh, uh, package created with some code, that may have some dependency on other packages. So what you will do is you will package everything together and give it, so that you reduce the dependency of having other packages. If somebody is actually taking your package and doing it, they don't have to go and fetch the dependency packages. You will already be including that in your thing. So that's why we use packages. So how to actually install packages? So the command to use that is pip install. So So here I'm just giving an example of requests. Request is the package. This is used to make HTTP requests to web applications. Any API, any API that is exposed via web. So you can make HTTP calls. The pip install is the command. Here I have given exclamator because in Jupyter it expects it, but normally you don't have to. If you just run it, it will add to it. Let me just run it. It's already there in my system, so it doesn't say uh, it's already there. Okay, and how do you use that package once installed in your program? You can use that by this command, which is import. So the any first any Python code that you write, you will first write this sentence: import this particular file or this function from this file. You can also say like import a function name from requests and all. Okay. So this is the command to import this. I will show you a demo of this. Okay. So let's import that here. This is how and then you will use that import whatever you have requested. I mean whatever you have imported with a syntax like this. You will this is a function. Get is a function of request. So you are specifying you are going to use requests module and giving a dot and this is a function, and it will need a parameter to get. So you are passing this URL value. So let's say what it is giving, and say we will check the response here. So this response has come, and it is actually going to tell whether it is success or not. We'll print it. It says okay, response code is 200, so it is success, and it gives the request response data as well. Okay, so this is one example of a package. There are many packages available. One of the exercise I'm going to give is for you to go ahead and import or install one package called Faker, which is going to which will help you generate fake information like name, phone numbers, and anything. It has a lot of functions, so you can play around with that. Okay, let's say you want to create packages for your programs that you are doing, right? So how will you do that? So here is a step. You can create your own packages. So you just have to create a new directory, a folder, right? And you will create a init file, init underscore init underscore dot py. So this will be the initialization of that package, and then you will add your modules to that. And optionally, if you are going to publish it, you will need a setup.py. We will not see that today. That is only for publishing. Okay. So let's see how to do that. Let's go to, so this is Python demo is a folder I have. Okay. So let's say I have this in the Visual Studio Code also. What I'm going to do is I'm going to create a new folder. So let's say I'm going to name it my package. So this is a here is where I'm going to package all my programs, right? So I created a folder. Inside this folder, let me create one new file that is going to be called hyphen init hyphen dot py. Okay, I created it, and I'm not going to add anything right now because I need to first add other components I want to add. Let's say I'm going to have two functions done by this package. One is going to be an addition, one is going to be a multiplication. So let me create a new file and call it addition.py, and it is just going to, I'm going to define a function in this file. Okay, so define add. I'll take two values x comma y, and I will return x plus y simply. Okay, so if somebody is using my package, if somebody is actually installing my package and saying okay, from my package I want to use this add function, they can just do it by import addition from my package, and then they will use like addition dot add. I'll show you how to do that. But currently I'm just creating the files. Let's do one more multiplication .py. Let's say multiply a comma b and return a star b. So these are two functions. I need to tell my package that okay, if, you should actually use these files if somebody is calling this my package, right? So we will go here to the init package and give me a minute. Okay. So here we will say include, okay, from no import dot addition. Sorry, yeah, 1 minute. Stop sharing. Yeah. Are you able to see my screen yet? No, right?
Not yet.
Okay. Now,
Yes, we can see.
okay. So this is going to be like this. From dot addition, which means that from the same folder, from the file addition, import add, and from multiplication, import multiply, which tells you that these add and multiply are going to be exposed, from this my package. So in case if you have many other functions here, they are not exposed because I have not added here. But if you want to expose them, you will have to add them also. Okay, so now this is a package. Let's say this package is available and I want to use this package in another program outside this package, right? So let's close this all. In this Python demo folder, I'm going to create another, let's say demo.py. This is going to be my program where I'm going to use this package, right? So I will be using import um, import addition from my package, import addition comma multiplication. So this will actually import these two, you know files, or import, let me see, no, it's actually going to be add and multiply, sorry, because those are the function names. So this is going to import add and multiply from this package, my package, and I will just say print add 23, print multiply 23. How to run this Python code. I think this is the first time some of you may be seeing .py file. You have been seeing the Jupyter notebook, but this is how you create a normal Python file. You will just write the same piece of code here and call it .py, and to run it, you just have to say Python and the file name. It is run, and you can see that the first is printed as add, the second line is printed as multiplication. So in this case, this is a standalone program that used a package which you created. And if you are going to package this and ship this, anybody else can use it by just doing this import statements. Hope this is clear. Any questions?
So here you are locally referencing a package like a folder structure, but when you do pip install, is it very similar to NuGet or npm package libraries that you register your package somewhere?
Yes, correct. Correct. So when you do pip install, it is similar to npm install. So that is going to get you all the files that is needed inside your folder,
Okay.
wherever you specify. I will show you that as well.
Okay.
Okay. Now another important thing. Okay. Now we know that how to create packages, how to install packages, right? And another important thing we need to know is virtual environments. So any project that you are starting, you will be actually, you want to hold your project dependencies within a specific environment, right? Otherwise, if it is installed globally, if any package that you are installing, if it is installed globally, that is going to be available for all projects or everywhere. We don't want to do that. When we are actually working on a project, we want to have our own environment created, and we will install all the packages and dependencies we want into that environment, so that when we ship it, we will ship only what is needed. Okay. So there is a concept called virtual environment. And so the way to do that, we first need to install virtual environment package in our terminal. Then we can use virtual environment, this package, to create a environment. Let's say, we'll go back to here. Okay. And here you can see that it is, before this line, it is showing base is actually a global environment. So whatever if we do a pip install here, then it is going to install that in a global environment. But we want to do it in a virtual environment, right? So the first command is pip install virtual env, which I have already given, and it is available. So I will not be creating now one. So then I'll do the next command, which is creating a virtual environment once you have installed this package, right? So for that, we first need to create a folder. Okay, let me create a folder called my project. This is going to be my virtual environment, let's say. Okay, within this, I'm going to have my virtual environment created. CD my project. Now, virtual env, this is a command, virtual env, and then the name of the environment that you want to create. The name of the environment I want to create is v demo. I call it, give a name as v, because it tells me that virtual environment, v demo slash bin slash activate. Oh, no, first I have to just give the create it. I'm just giving a v demo as a name. It is going to, it has created. We will go back and see in this folder my project. So there is a demo environment created, and there are some files available. If you go inside the lib, you can see python 3.8 is there, and there will be site packages. And this is the initial list of packages that are available. Okay, this is a basic package available for any environment. So that is available. On top of it, when we are actually going to install anything new, that is going to come here. We will see that. So everything will be within this python 3.8 and site packages. Okay, so let's go here. So we have created one, but we have not activated it, so we need to activate it. So you see base here still. So we are not into the environment. We have to move into the environment by giving source v demo is my environment, bin activate. If I do that, then you can see here vdemo is my environment now. Okay, now if I do a install, that is going to install whatever is needed into that particular environment. Let's say do requests. I'm installing the request package as we have seen in the previous one. So it's installing, everything is installed. Now you can go and see, here it is. This the one, yes, site packages. You can see if you, okay, until this point newly added. So you asked for requests, but you have got so many things because these are all the dependency packages for requests. Requests can work only if these different packages are available. So it is installing the dependents also. So that is what the pip install will do. It will not only install that particular one, it will install the required dependencies as well. Now you have your environment. If you want to ship your code to anywhere, you can just package it and ship it. So that is a separate, shipping is a separate one. We're not covering it here. So let me go back to this. And if you are in Windows, the command to do this is v demo slash scripts slash activate. If you are in Linux or Mac OS, this is the slash bin slash activate. Okay, that's all I wanted to cover today. And as I said, there is an exercise. So install the faker package and generate a list of fake user profiles, random names, email addresses, birth dates. Just play around and see how it works. So that's it from my end. Thanks everyone for joining.